Good morning, everyone.
Good morning.
Okay, today we want to talk about displacement in determinate truss structure. So, displacement in determinate truss structures. Okay. So, if you remember in previous lecture, we talked about internal force and external force in a determinate truss structure. We found external forces or reaction of support using three equations of equilibrium and also determine the internal forces in determinate truss structure using method of joint, method of section, and alternative method. Now we want to determine the third things in the analysis of the truss structure, which is displacement. To find displacement in determinate truss structure, we use a method. We call it virtual method. Virtual method. Or we call it unit load method. Unit load method. Because we use one unit load during the analysis of the structure. Even sometimes we call this method energy method. Energy method. Because we use the concept of conservation of the energy to create the formula of the displacement. You know the conservation of energy. Energy cannot be created or destroyed. Cannot be created, cannot be destroyed. Only can be altered, can be changed from one form to another form. Okay, later I will talk about this one. Before going to talk about the formulation of the virtual method, just I want to tell you, in this method, we have two kind of structure. We use two kind of structure in this method. The first, we call it real structure or real truss structure. And the second kind of structure, we call it virtual truss structure. So, when we want to analyze this structure using this method, we should draw the virtual truss structure. So, first of all, I want to tell you what is the meaning of virtual structure. Real structure is, we know already. For example, we have this kind of truss, just very simple truss. Okay, any simple truss like this. And let me put some loading here, here, here. For example, 20 kilonewton here, 10 kilonewton here, 10 kilonewton here. Let's put, is it okay? So A, this is joint A, joint B, joint C, joint D, joint E, F, G, and H. Okay? we consider this is our real structure, real truss. Okay? This is, we call it real truss structure. What's the question? For example, they ask us to find or to determine vertical displacement. So we want to determine vertical displacement at joint C. Okay? When we want to use this method, we should draw virtual truss structure. How to show virtual truss structure? We draw the same frame, exactly the same thing. This is the same frame of the truss with the same support reactions. A, B, C, D, E, F, G, and H. Okay? In virtual structure, we have to remove all the external load. No need to show external load in virtual structure. So the first, removing all external forces. Second step, we have to apply a unit load. We have to apply a unit load here. Where we have to apply unit load, we have to look at where they ask us to find displacement. At joint C. Okay, so we have to apply unit load at joint C. So how to apply unit load at joint C? I put it like this or like this, horizontal or vertical. I look at here. They ask us to determine vertical displacement. So I have to put one unit load at joint C vertically. Why? Because we want to determine vertical displacement. So, and we call this structure, we call it virtual structure or virtual truss structure. So, virtual structure is a structure with applying a unit load at the point that we want to find displacement by removing all external forces and applying the one unit load. So, is it clear, guys, how to create, how to show the virtual structure in truss?
Yeah, doctor.
So, maybe, okay, let me just, I write some explanation here for your reference. Virtual structure, okay? Virtual structure can be created by removing all external forces, by removing all external forces and applying an unit load, okay, and applying an unit load when at the point that we want to, which point? That we want to determine displacement, that we want to determine displacement. Okay? If they ask us to determine horizontal displacement, we have to put it horizontally. If they ask us to find vertical displacement, we have to put it vertically. So this is, let me show you one more example. This is, we have this truss structure. Okay, let's put one pin support here and one ruler support here. So, okay, this is A, B, C, D. Okay, let's have, okay, C, let's have at point C, 20 kilonewton load. Okay, this is our real structure. So, this is up to us. We can put also another force here, 10 kilonewton horizontally. We want to show virtual structure. Okay, I will show the main frame of the structure. I have to show the support reaction. So, removing all external forces, okay, we have to look at the question. The question asks us to determine horizontal displacement at point C here. Okay, this is point C. So, how to show virtual structure? Removing all the external force, look at point C, and they ask us horizontal displacement. So I put here 1 unit load here. Okay? Is it clear, guys? Any question? Please ask.
No question, Doctor.
Okay.
Yes,
So please, if anything is unclear, let me know to explain more, to make sure you understand the concept. Why we need virtual structure? Because for the analysis of the truss structure, we need it. Later I will explain. Okay? For calculation of the displacement, we need at the same time to analysis a real structure, also analysis the virtual structure. What is the meaning of analysis? We need to find all the internal forces in the real structure. Okay, you remember from the method of joint, we use this one, for example, FADA, FADB, FADC, and so on. Okay. Also, we need to calculate all the internal forces in virtual structure. Okay. Because these forces, they are not same, because already we remove the external forces. So support reaction will be changed, all these forces will be changed. We show internal forces in virtual structure with the letter of mu. For example, mu dA here, mu dB, mu dC, and so on for BC, for AB. So F means internal forces in real structure, mu internal forces in virtual structure. We have to calculate these things to determine the displacement in determinate structures. Let me show you one more example about the real structure and about virtual structure. Okay, let's have a truss like this so we can, this is one pin, one ruler support. Okay, okay, let's have a different kind of loading. This is 30, this is 20, this is 20 kilonewton. Okay, any kind of loading we can. So this is our real structure. How to show virtual structure? So will be the same frame. Same supports. So we can remove, we have to remove all, and we have to look at the question. For example, this is A, B, C, D, E, F, G, and H. So the question is find vertical displacement at point, for example, G. Okay? They ask us displacement vertical at point G. So we remove all the external forces and we have to put at point G. This is point G. A, B, C, D, E, F, G, and H. Okay? So we have to put unit load at point G and we have to locate it vertically. That's all. So we call this one virtual truss structure. And this is the real that is given to us already. Any question, guys?
No.
No. Okay. Okay, guys. Now, what we want to do, we want to go through the formulation, very simple formulation of the displacement, how to find displacement. Why we call it this method virtual method? Because we have a virtual structure. Why we call it unit load method? Because we use unit load at the point that we want to find displacement. Why we call it energy method? Let's show you. Okay, what is the meaning of energy, guys? Energy or work means force time displacement. Okay, so we have a work or less external work. Okay, what is the meaning of external work? You know from the high school, so when we have this is force, we will have a displacement. So like this, okay? So that means work because of the external forces, so should be force times displacement. Force times displacement. We know already. When we have a external work, we should have also internal work. Why? To prevent the deformation. That means external work or external loads applied to a structure make it deform. So we need internal work to prevent the deformation. So we should have internal work or internal energy. Okay? So internal, we show mu, I told you, forces times internally displacement. That means if we have a force here, okay, doesn't matter, force be tension or compression. So due to the, for example, this tension, we will have a elongation. This is delta L. You know it from the mechanic of the material. So in mechanic of material, how to find this deformation? You remember? We assume if we have a elastic, so sigma is equal, stress is equal to modulus of elasticity times strain. Okay, what is the meaning of stress? What is the meaning of stress? Stress is force over area. You remember? Internal forces in the real structure over area. This is modulus of elasticity. What is the meaning of strain? Strain is delta L over original length. So delta L over L. We are looking for delta L. So delta L is FL over AE. This is, you know already from strength of material or mechanic of material. So I can replace here mu delta L should be FL over AE. You follow me, guys?
Yes.
Yes.
So this is external work or external energy. Let's show it with the letter of W. This is internal work. Let's show it with the letter of U. Based on the conservation of the energy, energy cannot be created, also cannot be destroyed, but can be altered from one to another. So that means W should be equal to U. That means P times delta is equal to mu F L over AE. Method. the name of method is unit load method. Unit load method means, as I show you in a virtual structure, our external load in virtual structure was equal to unit. Clear? We put one unit load. So 1 times delta. We are looking for displacement. You are looking for displacement delta. So we can conclude that delta is equal to mu F L over AE. This is displacement only for one member. We have to use this formula to find displacement in determinate structure. Okay. What is the meaning of F? You know already F, guys. F is the internal forces. Let me write for you. F is internal force in real structure for each member. For each member. Okay? How to find this one? Using method of joint, as we talk about it in previous chapter. You know, using method of joint, or you can use alternative method. What is mu? Same internal force, but in virtual structure for each member. For this reason, we need to show the virtual structure, because for each member of virtual structure, we have to find internal force. What is the meaning of L? Length of each member of truss. L. Length of each member of truss. What is the meaning of A? You know already. Cross-sectional area. Cross-sectional area of each member of truss. E, you know already, modulus of elasticity for each member. So, of course, if all member has one material, so E for all of them will be the same. Okay? This is deformation or displacement for one member. Okay? But we have to consider for all members. So we show it like this: summation of mu FL over AE. What is the meaning of summation of this one? Means, for example, let's show you this truss. So I will solve several examples and no need to be worried. It's very easy method. Okay, let's this one. we have this truss A, B, C, and D. Okay? How apply this one? This formula for this? First of all, you have to show the virtual structure. For example, the question is determine vertical displacement at point C. Okay? So this is virtual structure. So I show you. Actually, I don't want to calculate it. Just I want to show you how to apply this formula. So we want to determine vertical displacement at point C. So in virtual, I remove external loads. And now I have to apply unit load at point C vertically. Okay, this is virtual. So how to show this one? I want to find displacement vertically at point C. What is the meaning of this formula? This formula is summation means for all the members. So let's start with member AB. So that means mu AB times FAB times LAB over AE. If cross section different, this one should be AAB. Area of AB. Sometimes the area is different. Usually the cross-sectional area of the bracing is smaller than the cross-section of area of main member. And sometimes the area for all members same. If same, just write it A. Okay, also E. This is for member AB plus. For all 5 members, we have to write this. So mu BC, FBC, LBC, ABC times E plus for all members. What is mu AB? Internal force here. If assume tension, this is here. Mu AB. How to find it? Method of joint. What is FAB? FAB in real structure. As I already show you. This is FAB. What is mu BC? This one. Can be this one. Mu BC. Here is FBC. Okay? By the way, no need to calculate like this. So I will show you a table so you can set up a simple table. So without directly doing this one, using the table, easily you can find the displacement. Any question, guys?
No, Doctor.
So I hope you understand the concept of the virtual work method to find displacement in determinate truss structures. I think the best thing is I start with the very simple example and implement all the steps and show you the procedure. So as you can see, at the end, we want to use this formula. And in this formula, we have to analyze the real structure. We have to analyze the virtual structure. And after that, put all our data, all the results of analysis in this formula. This is a method, virtual method or unit load method. So let me you can see here, guys, clearly.
Yes, Doctor.
Yes.
Yes, Doctor.
Okay. Sorry, guys, I'm running the lecture from my office, so the whiteboard is not same as a class. It's not big. Okay. Let's go through the example. What's the question? This is we have just I want to show you very simple truss to understand the procedure better. Okay, we have a truss with a 3-member. Okay, let's have a horizontal force of 4 kilonewton. What's the question? We want to determine vertical displacement at point C. Okay. So we apply horizontal load of 4 kilonewton at joint C, and we want to determine displacement at joint C due to this load. Because when we apply a load, on any kind of structure, this is load, this is a structure, a beam or any structure. Due to the load, we will have a displacement. Okay? So we want to find this. So cross-sectional area for all members are same. So we assume it 400 millimeter square. And modulus of elasticity also will be 200 gigapascal. Okay, so first step in trusses, always you check determinacy. externally determinate C and internally determinate C. So let me, I put the step 1, check determinate C. Okay? So the first of all, this is pin support. We have the two reaction, AX and AY. Ruler support, this is one reaction, here Y. Okay? So, can you tell me this simple truss externally determinate or indeterminate? Externally. This truss is externally determinate or indeterminate? Any comment?
Statically determinate.
Determinate. Why? Because we have a 3 unknown. So we have a 3 unknowns, 3 support reaction unknowns, and we have 3 equation of equilibrium. Correct? So we have 3 unknown, 3 equations, so we can solve it. So we say externally determinate. Clear? Let's check how about internally. Internally, how many members we have? How many members?
3.
Members. 3. AB, BC, and AC. Correct? We have a 3 member. This is 2J minus R. How many joint? 3. How many reaction? 3. So should be 3. So you can look at 3 members, 3 equal to the 3. So that means our truss internally also is determinate. Internally determinate. So that means this truss in both externally and internally is determinate. Okay? If we have this one pin, if we have this one also pin, so our unknown will be more than equation of equilibrium. So our structure will be indeterminate but externally. Okay? In next chapter we will talk about indeterminate truss structures also. Okay. Second step. What is the second step? We look at the formula. What we need? We need F. What is F? Internal force in real structure. That means for all members, we have to calculate internal forces. Okay, so let me put step number 2, analysis of real structure, because I need F. How to analysis? You can directly go through the method of joint. Before that, you have to calculate support reaction. So you know already. So to find support reaction, summation of Fx is equal to 0. So we have a 2 force in x-axis, so should be 4 minus AX. So AX will be how much?
4.
Yes, 4 kilonewton. Summation of Fy equal to 0. So we have a by minus ay. You know already choosing the direction is optional, doesn't matter. Okay? How many force we have? by, I choose upward, positive, and ay, I choose downward, negative, is equal to 0. So that means by should be equal to ay. After that, we need to apply moment because we have a 2 unknown. So we need one more equation. So you can apply moment about point A or B. So I choose apply moment about point A. So for AX and AY, there is no any moment because we don't have perpendicular distance. So that means no moment. So we have to find the moment for 4 kilonewton and by. So 4 kilonewton, how to rotate about point A? So should be 4 kilonewton times perpendicular distance, which is 3. So should be 4 times 3 clockwise. So should be 4 times 3 by. How to rotate about point A? Counterclockwise or anti-clockwise. So minus 8 times by is equal to 0. So by should be 12 over 8. So 1.5 kilonewton. So ay also will be 1.5 kilonewton. So these are support reaction. Now we have to go and find internal forces in truss. You are okay, guys, so far?
Okay.
Okay.
Okay, so let's continue analysis of real structure here. So this is real structure. Okay, we have a 4 kilonewton here. AY 1.5 kilonewton. BY also same opposite direction 1.5 kilonewton. AX is 4, here is 4 kilonewton. Okay, so this is A, B, and C. So you know already how to use method of joint, okay, from previous chapter. Joint by joint, you can choose. You can start from joint A or joint B. Okay? For example, start from joint A. Joint A. We have a 1.5 here, 4 kilonewton here, and we have a this force, FASC. Okay? I assume it in tension, as you know. So, to find, so we have to resolve this force into the two forces, FAC. So, okay, also we have AB, FAAB. Okay, this is FAC cosine alpha, if this one alpha, and this is FAC sine alpha. So I resolve it. This force to the two component in x and y axis. So easily you can find FAAC and also FAAB. So you have to use the two equation of equilibrium for joint A, for example. Cosine alpha is how much? Cosine alpha, if this one alpha. So in this right triangle, this should be adjacent, which is 4 over hypotenuse. This is 4, this is 3. So this one should be 5. Okay? Sine alpha will be 3 over 5, means 0.6. So we have only two forces in x-axis. So FAC cosine alpha, or 0.8 FAC positive minus 4 is equal to 0. So very easy. You can directly find FAC will be 4 over 0.8 or 40 over 8. Okay? So it should be how much? Sorry guys, I forgot this force. We have another force in x-axis, FAB. So plus FAB minus 4 equal to 0. Okay? So we have a two unknown. So we have to go through the summation of all forces in y-axis equal to 0. In y-axis only we have a two force. So FAC sine alpha, which is 0.6, FAC minus 1.5 equal to 0. So from here, directly we can find FAC. Okay? FAC should be 1.5 over 0.6. So it should be 2.5 kilonewton, which is positive. That means is tension. So what is the meaning? FAC is 1. How much? How much, guys? 2.5 kilonewton in tension. You follow me, guys?
Yes, doctor.
So you substitute 2.5 kilonewton in this equation and you can find directly FAB. So FAB equal to 4 minus 0.8 times 2.5. So FAB will be how much?
2.5.
2 kilonewton. No, FAB should be 2. This should be 2, 4 minus 2 should be 2. So that means FAB also positive. That means is tension. So that means this is. So should be 2 kilonewton in tension. So, and at the end you have to find for member BC. Okay? For member BC. So you can use the joint B. So joint B, so 1.5 kilonewton. Here we have a force already calculated 2 kilonewton. So only we need to find FBC. Okay, you have to do the same thing and find FABC. Okay, you do the same procedure into the two force, FABC sine alpha, FABC cosine alpha, and you can, for example, only apply one of them, okay, in x-axis or y-axis. For example, summation of FAY equal to 0. So it should be FABC sine alpha means 0.6 FABC positive plus 1.5 equal to 0. So FABC will be negative 1.5 over 0.6 should be negative 2.5 kilonewton. So that means FABC is compression. That means it's like this, compression. Compression. So we put 2.5 compression. So this is the analysis of the real structure. As you know already, how to analysis the truss using the method of joint, or you can easily use the alternative method. Even no need to show the free body diagram of the joints. Okay, so after that we go to the third step, step 3. Step 3 is analysis of virtual structure, virtual truss. So first of all, we have to show the virtual structure. So this is the virtual truss. How to show virtual truss? Remove external force, okay, and add unit load at which point? At point C. Which direction? Vertically. Vertically at point C. So this is point C. I put it vertically at point C. Doesn't matter upward or downward. So I put it upward. So this is A, B, and C. Same procedure. Same procedure. First, we have to find support reaction. After that, one by one, we have to find the internal forces in virtual structure. Okay, so let's assume this one, AX, AY. Okay, this is BY. Okay, so in virtual structure, summation of Fx equal to 0. So that means Ax is equal to 0 because only we have a one force. So to be balanced should be equal to 0. Summation of Fy equal to 0. So Ay, Bay, and 1. We have a 3. So I choose upward. So should be minus Ay minus By plus 1 equal to 0. Or Ay plus By should be equal to 1. Okay? So we go through the summation of moment about point A. Apply moment. So By rotate clockwise. By times what?
8.
By times 8. So 8 By. This is 1. How to rotate? Counterclockwise. 1 times which number?
3.
4. See, 4. Okay? See this one? 4 meter, 4 meter. For load is vertical. So distance should be horizontal. Clear? So By should be how much? 48. So should be 0.5 kilonewton. So we substitute here. Ay also will be equal to 0.5 kilonewton. So that means this is 0.5, 0.5, and this is equal to 0. Okay. Now we have to find internal forces using method of joint. So, for example, for joint A, we have a 0.5 here. Here is 0. We have a mu A B. Because in virtual, we show it with the mu, not with the F. And here, mu A C. Okay? So, we have to resolve this force into the two force. So it should be the same angle, mu AC cosine alpha, mu AC sine alpha. So this is joint A. So you can use summation of fx equal to 0. Cosine alpha is 0.8 mu AC plus mu AB equal to 0. Summation of Fy equal to 0 for joint A. So should be mu AC sine alpha or 0.6 mu AC minus 0.5 equal to 0. So from here directly you can mu AC. You can find it. So mu AC will be how much? 0.836 kilonewton positive. If you replace it here in this equation, you can find mu AB. Okay? Mu AB will be negative 0.67 kilonewton. So, AB is a negative, means compression 0.67 compression. I didn't mention negative here because already changed the direction because it's a compression. When you show compression means negative. Okay. Mu ASC. ASC is a tension. We already find it. 0.836 tension. Okay? No, you have to find mu A BSC. So you can go through the joint B. See? In joint B, we have a 0.5 kilonewton. We have a compression of 0.67 kilonewton. And we have a mu BSC. Okay? Also, I resolve it to the mu BSC sine alpha and mu BSC cosine alpha. Okay? And simply you can find, for example, use the summation of f of y equal to 0. So mu BSC sine alpha, which is 0.6 positive minus 0.5 equal to 0. So you can find mu BSC 0.5 over 0.6 should be 5 over 6. So it should be 0.836, same as this one. Positive. Positive means tension. So this is 0.836 tension. You can see so far nothing new. You know already method of joint. Just this part look as a revision of the method of joint. Any question, guys? Please.
No
So far,
questions.
so good.
So is it clear? Everything is okay? Clear? Okay.
Yes, everything clear.
Can I clear this part, guys?
Yes, you can clear
So
that part.
Okay. Let's go to the last step. Last step. We want to use this formula, guys. Displacement is summation of mu F L over AE. I want to set up a table, so let's set up a table. Okay. Instead of using directly this formula, just I want to set up a table. I believe it will be more easier for the students to directly use it. Okay. Set up a table and apply this formula. Okay. We have 3 members. So member AB, AC, and BC. So this is members, member AB, member AC, and member BC. Okay? What we have in the formula? We need lengths of each member. Okay. We need F, internal forces in real truss. We need internal forces in virtual truss. Okay? We need multiplication of mu FL. This is optional, but I put a mu FL. Multiplication of these three. We need AE at the denominator of this equation. AE. Okay? And at the end, we need to find delta mu F L over AE. This is delta here for member AB. Here, delta for member AC. And here, displacement for member BC. But we need summation of all displacement. So I put here summation. We need here. We need displace. Because all displacement in member AB, AC, BC, we should add. This will be our answer. This one will be vertical displacement at point C. Okay, so let's put lengths based on the meter, F based on the kilonewton, mu kilonewton. Okay. And of course, this one delta will be based on the meter because everything meter. Length of AB is how much? You tell me.
8.
8 meter. Okay, how about length of AC?
5.
5. Very good, because this is 4, this is 3, so hypotenuse will be 5. Length of BC? BC how much?
5.
Also 5. Okay. FAB is how much? AB. How much? 2. Clear? AC how much? 2.5. BC how much? BC 2.5, but is compression. So we have to write minus 2.5. AB and AC were in tension. Okay, guys? So be careful about negative or positive. If compression, you have to make sure to put negative. Okay. Mu AB is how much? You tell me fast.
Negative 0.67.
That's great. Because compression. AC is how much? (836), also BC 836. Okay. This is very easy, just multiplication of these three. So I found it minus 10.72, this one 10.45, and these two exactly the same, negative. Okay? AE is how much? A was how much, guys?
400 millimeter square.
400 millimeter square, correct? But everything is based on the meter. So how to convert millimeter square to the meter square. So we have to times it into the 10 power minus 6. Clear? So it should be 4 times 10 power minus 4 meter square. E is how much?
200 gigapascal.
200 gigapascal. What is the meaning of giga? Times 10 power?
9.
Very good. What is the meaning of Pascal? What is the meaning of Pascal, guys?
Newton per
Means
millimeter.
Newton per meter square. Correct? Correct? Meter square is okay, but in Pascal, the unit of force is Newton. But our force are all kilonewton. So we have to times it to the 10 power minus 3 to change it to the kilonewton. Clear? Yes? So it should be 2. This is 2, 0, 10 power 11 minus 3. 2 times 10 power 8. Okay? Kilonewton per meter square. Or kilopascal. So AE is how much? This you have to multiply 4 times 10 power minus 4 times 2 times 10 power 8. So it should be 8 times 10 power 4. Okay? Multiplication these two meter square with meter square will be removed, so will be kilonewton. So AE is based on the kilonewton. So I have to write here 8 times 10 power 4. 8 times 10 power 4 kilonewton. So far, okay, guys?
Okay, sir.
Okay. So just you have to, this one, divided this number to this. This is and right here. So if you do, will be minus 0.134 times 10 power minus 3. This one should be 1306 times 10 power minus 3, so it should be negative 1306 times 10 power minus 3. Okay? So we need summation. We need summation of this. That means we have to add these 3. So these two exactly same opposite should be 0. So will be, our answer will be this one, minus 0.134 times 10 power minus 3. So that means displacement vertical at point C will be equal to minus 0.134 times 10 power minus 3 meter, or equal to minus 134 millimeter. Just I want to show you that displacement is very, very, very small amount. So you can see, if you find it 1 meter, if you find it, I don't know, 50 centimeter, 10, even 20, something like this, big number, that means something wrong, and you have to double check. So very small. What is the meaning of negative? Means our displacement is a kind of shortening, is a kind of compression. That's all, guys. This is displacement at point C. I hope you got the concept of the virtual work or unit load method to find displacement in determinate truss structure. So in next class, which will be face-to-face, I will solve more complicated example related to this method to make sure you understand it very well. Any question, guys? Any question, guys?
No, Rada.
No, Rada.